Ever wondered what it would take to prepare a Formula One champion for space? Lewis Hamilton, the king of speed on Earth, is considering gearing up for a journey that's literally out of this world. But how does a race car driver train to become an astronaut? Lewis Hamilton's fascination with space goes way back. In 2017, he toured NASA's Sonny Carter training facility in Houston, Texas, and was completely blown away. That visit lit a fire in him. He's been dreaming of becoming a space pilot ever since. Now he's chatting with Elon Musk about actually making it happen. Yeah, the guy behind SpaceX. It's crazy to think that Hamilton, a Formula One legend, is seriously looking at trading the racetrack for the stars. This isn't just about going to space. It's about Hamilton pushing his own limits and showing us all that the sky really isn't the limit anymore. First off, you might ask, why would Elon Musk choose Lewis Hamilton? Well, beyond his incredible talent on the track, Hamilton's curiosity about space and his passion for technology make him an ideal candidate. Plus, with commercial space travel on the rise, celebrities like him are helping bridge the gap between science fiction and reality. But what exactly does this training involve? To prepare for the extreme conditions of space, Hamilton would undergo intense physical and mental training. This includes zero-gravity simulations, where he experiences weightlessness just like astronauts do in space. Picture this, floating effortlessly, every movement becoming a calculated maneuver. It's not just a fun ride, it's crucial for understanding how to navigate in a zero-gravity environment. Now let's talk about the centrifuge training. This is where Hamilton would be spun at high speeds to simulate the intense G-forces experienced during a rocket launch and re-entry. These forces can be up to 5 times greater than gravity on Earth. Imagine your body feeling 5 times heavier than usual. This is a true test of physical endurance and mental toughness. Did you know that astronauts have to be proficient in basic medical skills? Hamilton's training will have to include learning how to handle medical emergencies in space. This is vital because in the vast expanse of space, help from Earth can be hours or even days away. Knowing how to handle potential health issues is a matter of life and death. Training also has to involve extensive classroom sessions. Hamilton would dive deep into the science of space travel, understanding the mechanics of the spacecraft, orbital dynamics, and the harsh environment of space. It's like going back to school, but with a much cooler syllabus. This knowledge is crucial for making informed decisions during the mission. One of the most fascinating parts of Hamilton's training would have to be the underwater simulations. Why underwater? Because underwater environments mimic the buoyancy of space. Here, Hamilton will practice extravehicular activities, EVAs, or spacewalks in a giant pool. This helps him master the skills needed to repair spacecraft or conduct scientific experiments in space. But training wouldn't just be physical and technical, it's also psychological. Hamilton undergoes rigorous mental conditioning to handle the isolation and confinement of space travel. Being away from Earth, family, and the familiar can be mentally taxing. Techniques like meditation and visualization help astronauts stay focused and calm under pressure. What's the end goal of all this training? For Hamilton, it's not just about the thrill of space travel. He's passionate about advancing human knowledge and inspiring the next generation of explorers. Imagine the impact of seeing one of the world's most famous athletes stepping onto another celestial body. It's a powerful message about what humanity can achieve. Hamilton's training would also involve understanding the environmental impact of space travel. He's keen on promoting sustainable practices, ensuring that our ventures into space don't harm our home planet. This aligns with his advocacy for environmental issues and adds another layer of significance to his journey. As he would progress through his training, Hamilton would also learn about the potential for space tourism. Companies like SpaceX and Blue Origin are making it possible for ordinary people to experience space. Hamilton's journey is paving the way for more accessible space travel, where the dream of going to space is no longer limited to professional astronauts. But how close are we really to widespread space tourism? While there are still many challenges to overcome, Hamilton's involvement brings us one step closer. His high-profile training and eventual journey could inspire significant advancements in technology and safety, making space travel more attainable for future generations. So, what's next for Hamilton? After completing his training, he'll embark on a mission that's more than just a personal achievement. It's a testament to human curiosity and our unending quest to explore the unknown. His journey will be a blend of intense preparation, groundbreaking technology, and sheer human spirit. Lewis Hamilton's journey to space is a perfect example of how the boundaries between disciplines like motorsport and astronautics are blurring. The precision and split-second decision-making required on a Formula One track are surprisingly similar to the skills needed in space. Both environments demand an unparalleled level of focus, coordination, and physical condition. In space, Hamilton will face the phenomenon of microgravity. Microgravity is a condition where objects appear to be weightless and free fall at the same rate as their surroundings. This is an incredible shift from the high G-forces he experiences in Formula One. Understanding how his body reacts to microgravity is crucial, as it affects everything from muscle function to fluid distribution in the body. One fascinating aspect of space travel is the concept of time dilation, a principle from Einstein's theory of relativity. In simple terms, the faster you travel, the slower time moves for you relative to someone who remains stationary. While Hamilton won't be traveling at near-light speeds, his experiences bring us closer to pondering the effects of high-speed travel on time, something Formula One enthusiasts can appreciate given the sport's obsession with fractions of a second. Hamilton's training will also highlight the importance of understanding the vacuum of space. Unlike Earth, space is a near-perfect vacuum with no air or atmospheric pressure. This presents unique challenges for spacecraft design and for the human body, which is accustomed to Earth's atmospheric pressure. During his training, Hamilton will learn about the life support systems that maintain a livable environment inside the spacecraft, ensuring a stable supply of oxygen and removal of carbon dioxide. Astrophysics plays a significant role in space travel, particularly in navigating the spacecraft. Hamilton's training will include understanding celestial mechanics, how planets, moons, and other celestial bodies interact gravitationally. This knowledge is essential for plotting a spacecraft's course and executing precise maneuvers in space, much like the precise driving required in Formula One. Another intriguing aspect of space exploration is the study of cosmic radiation. Space is filled with high-energy particles from the sun and distant stars, which can pose significant health risks to astronauts. Hamilton's training involves learning about radiation protection measures, such as shielding and dosimetry, to monitor and minimize exposure during his mission. Also, Hamilton's journey will provide valuable data on how the human body adapts to long-duration spaceflight. This research is crucial for future missions to Mars and beyond, where astronauts will spend extended periods in space. The insights gained from his experience will contribute to the development of countermeasures to mitigate the adverse effects of prolonged weightlessness, such as muscle atrophy and bone density loss. Hamilton's training would also include simulations of living and working on the International Space Station, ISS. The ISS serves as a microgravity laboratory where astronauts conduct experiments that are impossible on Earth. These experiments range from studying the behavior of fluids in microgravity to observing how plants grow without gravity. Hamilton's involvement in these experiments will help advance our understanding of fundamental scientific principles and their applications in space. Hamilton's preparation will have to emphasize the importance of teamwork and communication. Just like in Formula One, where success depends on seamless coordination between the driver and the pit crew, space missions require impeccable teamwork among astronauts, mission control, and support teams on Earth. Effective communication is critical, especially when dealing with the inevitable challenges and emergencies that arise during space missions. Hamilton's story is not just about a racing champion reaching for the stars. It's a narrative that blends the thrill of speed with the limitless possibilities of space exploration. It's a story of pushing boundaries, embracing the unknown, and inspiring millions. As we follow his journey, we're reminded that the sky is not the limit. It's just the beginning.